All right, so let's go ahead and do 832. Take a crack at this. I got to be honest, this section's a little bit disjointed for me, but I think there's some good lessons in here anyway. So as we go through 864, actually there's some very good lessons in here, but 864, team photo, we're just going to continue those ratios of similarity that we started on in 831. Alice has a 4x5 photo, and it's of the championship ice hockey team to celebrate their recent victory. The principal wants to make the the photo larger. So she goes to the print shop. She can go 7x9, 8x10, and 12x16, but she doesn't want it to cut anything off. So which should she choose? Well, the idea is that the ratios need to be the same if this is going to work. So whatever I multiply 4 by to get 7, I would have to multiply the same thing by to get 9. And I don't know. I mean, we could do the math on that. It doesn't look like it's going to be very easy to do. So let's just move along. Let's skip this one, which ends up being the answer, to do this one, and I'll show you what I mean. So 4 times 3 is 12. And 5 times 3 would have to be 15. So if this photo was 12 by 15, we could choose this one because it would have the same ratio. But it's by 16, so that doesn't work. And you're going to find that 4 times, I'll grab a calculator. You're going to multiply by 1.75. So 4 times 1.75 equals 7. So 5 times 1.75, if they were similar, would equal 9, but it doesn't. It equals 8.75, so that ratio is not as good either. So here, 4 doubles to 8, 5 doubles to 10. It seems like the 8 by 10 is definitely the way to go. And again, not surprising if you think about it. If you kind of visualize the 8 by 10, you're going to see that you have a 4 by 5 here, and a 4 by 5 here, and a 4 by 5 here, and a 4 by 5 here. Again, there's your 8 inches this way, there's your 10 inches this way, and it works out the way we would expect to see when we have a multiplier by 2 in this direction and a multiplier by 2 in this direction. We have 4 times more area, and again, that was something we explored in 831. Hopefully that's not a shock. So the cost to print Alice's 4 by 5 photo is 45 cents. Assuming that the cost per square inch of the photo is constant, how much should it cost to enlarge the bigger one? Well, again, we know it's 4 times bigger, so we'll just take 0.45 and we'll multiply it by 4. I believe that's going to be $1.80 is what we would expect to pay. Now, it's possible that they might charge more or less for a bigger photo, but in this, again, it's important they say that the cost stays the same. So you might not find that is true at CVS when you go to print pictures. Anyway, unbeknownst to her, the vice principal also orders an enlargement of Alice's photo. However, his enlargement costs $7.20. So, all right, let's take a look at this. He's multiplying this 45 cents. I don't know if you can hear my dog's barking. It's probably a squirrel or something. Anyway, it's this 45 cents times something equals 720. I'm going to divide by 0.45. That's 0.45. Gugh, my handwriting is something else. I tell you, very frustrating. Anyway, so again, I have my handy calculator, and I know that x is going to equal 7.2 divided by 0.45. I get, I didn't push the numbers in right. 7.2 divided by 0.45, I get 16 times bigger. So if it's 16 times bigger, it stands to reason that it's 4 times in this direction and 4 times in this direction. So it looks like the bigger one is going to be a 4 times 4 is 16, and 5 times 4 is 20. So he ordered a 16 by 20. Again, if we think about what that means, there's our 4, 8, 12, 16 inches. There's our 5, 10, 15, 20 inches. So 16 by 20 actually has 16 times more area than a 4 by 5 does. Again, all that goes back to the last section, 831. Okay, so let's go. So far, you've discovered and used relationships between the area and the corresponding side lengths of similar figures. But how are perimeters of similar figures related? Analyze the pair of similar shapes below. For each pair, calculate the areas and perimeters and complete the table like the one shown below. To help see patterns, write fractions in lowest terms or calculate corresponding decimal values. I'm going to put an A right here because I'm going to change this when I do B, and I'm going to change this when I do C. So the ratio of the sides, well, it looks like it's 15 to 25, right? So that's the ratio of the sides, is it's going to be 15 to 25, except for I can simplify that, right? 5 goes into both of these numbers, so it's actually going to be 3 to 5, right? And if it's 3 to 5, then this one is going to end up being 10, I believe, right? So 6 times, no, I don't want to do that. So 15 times something equals 25. I divide by 15. I think that's why I have it wrong. So x is going to be 5/3. I put the smaller one on top, so that was going to be my issue there. So anyways, if I multiply 6 by 5/3, there's my 10 that I got right there. All right, so the perimeter here is going to be 21 times 2, so it's 42. The perimeter here is going to be 25 times 2. 35 times 2, so it's going to be 70. Hopefully no questions on the perimeters. So the ratio of the perimeters, well, I'm looking for a number that goes into 42 and 70. I think 7 does. So 7 is going to go in here, 6 out of 10. And then again, 2 does, so I have 3 to 5. So look at that. My ratio of the perimeter is the same as the ratio of the sides. That makes a lot of sense, because if I went ahead and stretched both of these things out, you'd see I have a 6 and a 15 and a 6 and a 15, because perimeters in one dimension. 10 and 25 and 10 and 25. Again, just kind of imagine that you took your fence around a yard and straightened it out. It's in one dimension. Now you turn it into 2 dimensions to kind of keep your yard gone. But if I rip this plank out, I could put it right next to this one, etc., and it would look like this. The area, however, is going to be a little different. The area is talking about how much lawn seed you would need. So 6 times 15 would be 90, and here 10 times 25 would be 250. So if I simplify that, obviously, you can barely read this, sorry. That's supposed to be a 250. So obviously I can just lop off the 10s there, and I get 9 over 25. And again, not surprising. 3 squared is 9, 5 squared is 25. So the ratio area is square, and the perimeter areas don't. They're the same. Again, hopefully that's something we're all comfortable with, that we discussed last section in 831. All right, I'm going to erase this now, and I'm going to make myself have a little bit of room for B. And on B, you'll see that what I want to do here is I'm just going to sort of knock this thing right up on its side. So this is a 60 degree, and then the hypotenuse is 4. So I just sort of rotated this thing up. I hope you guys are all okay with that. This would be a 30 degree. This would be a 30 degree. I don't know if you guys recall, but we have ourselves, I'll get rid of that now because I'm going to use this one. We have ourselves a special right triangle. It's as easy as 1, 2, square root of 3. And again, if this is 2, that must be 1. So it doubles. And this would be the square root of 3. So the question is, what are the ratio of the sides? And I don't want to get too much into the perimeter because it's got the square root. I mean, I guess I will. It's fine. So the ratio of the sides, it looks like it's 6 to 2, which becomes 3 to 1, right? So this one is 3 times bigger than this one. And again, I think I'm kind of doing this backwards. Maybe I should go 1 to 3. Oh yeah, there we go. We have a large figure on bottom and the small figure on top. I completely missed that for the first one. So if I had the first one backwards, I apologize. I literally just noticed that. So they want the small one on top and the big one on bottom. So 1/3. Again, if I had it backwards on the previous problem, I apologize. Hopefully you guys can fix that for me. Anyways, the perimeter of the small figure is 6 plus 2 times the square root of 3. So 6 plus 2 times the square root of 3. I'm just going to pop that in the calculator and use decimals, even though I usually don't love decimals. I know that you guys do. So I get 9.464. 9.464, my mistake. Here, I'm going to get 18 plus 6 times the square root of 3. You can already see 6 times 3, 2 times square root of 3 times 3. So there's no reason not to think that this thing is going to end up being 1/3 as well. But 18 plus 6 times the square root of 3 ends up equaling 28.39 about. Again, these aren't exact. 28.39, and if I divide this by 9.464101615, I get 1/3. So again, just like we talked about in the previous problem, we have that same ratio of similarity when it comes to perimeter. The area, however, is different. So the area here, again, if you guys remember, the area of a triangle is half of base times height. I think that's a pretty easy way to do it. Half of 6 is 3. 3 times 6 is 18 times the square root of 3. Oh, shoot. I'm supposed to be doing the small. That's the big one, my mistake. So I'm going to change this. The big one is 18 times the square root of 3. The small one, again, half of 2 is 1. 1 times 2 times square root of 3 is 2 times square root of 3. And not surprisingly, if we do the math on this, we're going to see that the square root of 3's cancel. And then 2 over 18 is 1 over 9. So our area, actually, I guess I can write that out if I need to. So let me do that again. So I have 2 times the square root of 3 over 18 times the square root of 3. These are going to cancel. 2 over 9. 2 over 18 is 1 over 9. So again, you'll notice 1 squared is 1, 3 squared is 9. So we get that squared area, which again goes back to 831. So sort of beating a dead horse here, doing it over and over. I will erase all this, and we will go ahead and do C. You'll notice we have a trapezoid, and a trapezoid is, I'm sorry, I'm responding to a text right now. It's so weird to make these videos, and I guess I wonder if anyone's ever gonna hear that in the middle of a video I responded to a text. I suspect the answer is no. But anyways, on a trapezoid, we go here, and the idea would be, we already know these things are similar, so I can really just multiply by, it looks like 8, right? So this is gonna be 5 times 8, this is 5 times 8, this is going to be 13 times 8, which is going to be 104, I believe. So when I do my ratio of the sides, it's going to be 5 to 40, which ends up being 1 to 8. Now my perimeter here is 5, 10, 15, 28. Here it's 40, 80, 120. So I get 224, it looks like. Now what I'm going to do is I'm going to see if I simplify this. I know 2 goes into both of these, so I'll go 14 and 112. 2 goes into both of these, 7 and 56, and 7 goes into both of these, 1 over 8. So look at that. Just like we expected to see, the ratio of the perimeters are the same. As far as the area, I don't know if you guys know the area of a trapezoid. It is going to be base 1 plus base 2 divided by 2. Essentially, you're going to take the average of these bases, because that'll give you the middle, right? And then times the height. So you're essentially turning this thing into a rectangle is what you're doing, because you're getting the midpoint here, and then multiplying by the height. So again, the middle of this, and turning this thing into sort of a rectangle is what we're doing. That's why that's the... I guess I didn't finish this. That's why that's going to be the formula, times h. So when we go here, 40, 40, and this one was 104. Okay, so I know that if this is 13 minus 5 is 8, I have 8 to distribute here and here. Well, I'm going to put half over here. Half of 8 is 4. So I know, maybe I should put it in here so I'm not confused. I know that the whole side is 13, but I know that this little chunk is 4. Well, this is a 3, 4, 5 triangle, so that height must be 3, because 3 squared, Pythagorean theorem, right? 3 squared plus 4 squared equals 5 squared. 3, 4, 5, the most famous right triangle. Now, here's the beauty of this. Again, I can just multiply by 8. So 4 times 8 is 32, and 3 times 8 is 24. I guess I don't really care about this 32 as much as I do this 24 because I want that height. So when I figure out the area, it's base 1 plus base 2, 5 plus 13, divided by 2, times a height of 3. So I'm going to get 18 divided by 2. I'm going to get 9 times 3. I'm going to get an area of 27 over here. On this one, it's going to be base 1 plus base 2 divided by 2 over, multiplied by height. So 144 divided by 2 is 72. 72 times 24 is going to be, again with my calculator, is going to be 1728. And if I do the math on this, I'm kind of expecting that if it's 8 and 8, it should be 64. So this formula should be 64. If I divide 27 by 27, I get 1. If I divide 1728, and I'm doing this on the calculator, by 64, I suspect I'll get 27, and I'm sorry if I did that backwards. If I divide 1728 by 27, I should get 64, and I do. And again, there we see 1 squared is 1, 8 squared is 64. So that's our summarizing. That's our perimeters are related. The perimeters have the same ratio as the sides, but the areas have a squared ratio of the sides. Hopefully we're good on that. At that point, I believe I'm going to discard this and open up the next one. So we're going to go 832B. All right. Not a huge fan of this problem. Don't exactly love it, but whatever. Alice's friend Batcha finds an online print shop that also makes enlargements, but they use the metric system. Ugh. She tells Alice that they should use this business because it's only half a cent per square centimeter. Nobody knows what that means, so we're going to have to figure that out. That's way less than the cost of the local place. Alice is not sure since the units are not the same, and she thinks they should do some more careful calculations and conversions. So what is the unit cost in cents per square inch for enlargements at the local print shop that Alice found in 864? Well, if you'll remember, we knew that it was 4 by 5, right? It was 4 by 5, which is 20 inches squared. And we know that she was paying 45 cents for that. So if we want to know how much is the price, what's the unit cost in cents, right? So we're going to divide 45 cents by 20, and we're going to get 2.25 cents an inch squared. So that's what it's going to cost. 2.25 cents for every inch squared. You'll notice that there's 20 inches squared, so if I multiply 2.25 by 20, I would expect to get 45 cents, and I do. So that's how much I pay per square inch. And again, don't forget, we're saying 2, 3, 4, 5, 2, 3, 4. That's how much one of these little chunks cost. One of these little chunks costs 2.25 cents, I should say. All right. So if there's 2.54 centimeters in a square inch, so let's take a look at this. There's 2.54 centimeters in an inch, and there's 2.54 centimeters in an inch. Well, hopefully it's obvious to everyone. We should multiply those, or square 2.54, and that'll give us 6.45 centimeters squared. So again, 2.45 times 2.45 is going to give us 6.4516 centimeters squared in 1 inch squared. So again, we're kind of breaking this up. 2.5, 2.5. That's 1, 2, 3, 4. and then these add up to 56.4. So now we're able to sort of begin to make this comparison. I know how much I'm paying over here for a square inch. I know over here that I have 6.45 centimeters squared in an inch. So the question is, what's the unit cost in cents per square centimeter up here? Well, if I'm paying 2.25 cents a square inch, and if there's 6.4516, oh geez, I just realized I did the whole thing wrong. I put 2.45. This should be 2.54. I'm sorry. So hopefully you guys caught that error. I'm going to try and make a note of that and correct that in the upload, although I probably will forget. So whenever you see errors, please feel free to reach out to me and point them out, especially if they're not in the comment section. Well, I guess if they're in the comments, I should already know about them, so don't bother telling me. So anyway, I get 6.4516. I don't know if that was the number I had before. Maybe I wrote it up here wrong and used the right one, or maybe I didn't. I don't know. Long story short, I know that if I have 2.25 cents per square inch, but I have 6.4516. I think those are the numbers I use, so maybe I just transpose that number. If I divide that, I get 2.25 divided by 6.4516. I'm going to get 34. I'm going to get about 35 cents. About 35 cents per centimeter. Actually, no. I moved the decimal and I shouldn't have. I'm getting a little wonky right now. Maybe I need to take a break. About 0.35 cents per centimeter squared. So this is what the first place did when we were going by inch. This is what the second place is when they're charging by square centimeter. Well, you can see if we compare centimeter to centimeter, the first place is actually still cheaper. Again, I made a bit of a mess right here. I think in my notes I used the wrong number, so I kind of noticed that the number's wrong. Plus, I obviously can transpose that 2.45. I'm pretty sure I had 2.45 there instead of 2.54. But I think I caught my error, so I don't think it's as bad as I thought. Anyway, I'll watch it back and maybe make a comment if I deem it worthy. In the end, I think we're okay with this. So moving along. Jesse, by the way, the problem I have with that problem is it's just so overly back and forth and technical instead of just I don't feel like we're learning anything. I feel like we're doing a super difficult rigorous problem out of nowhere for no reason. Anyways, Jesse wonders if the two figures below are similar. Decide with your team there's enough information to determine if the shapes are similar. Well, what they want you to say is this. Oh, look. It's times 3. So if this is times 3, this area would be 9 times bigger, and 40 times 9 is 360, so yeah, they're similar. But it actually turns out that we don't know that the shapes are the same. Just because this is 3 times bigger and the areas are the same and they look the same, it doesn't mean that they are the same. You can manipulate the shape and still get the same area but not have it be similar. Remember, similar means same shape and same size, and we don't have enough to prove that it's the same shape. Just because it's a proportional size doesn't mean that the shape goes along with that. So just be aware. I guess, I don't know if this makes sense. Yeah, I can't do that example. That would be terrible. I'll get partway down and realize I can't do that. Anyway, so just like I said, we'll just leave it at that. The shape's not necessarily the same. Your teacher enlarges the figure below so that the area is a similar polygon with 900. So this is not going to look like it's supposed to, but let's pretend that these look the same. And now my area is 900 centimeters squared. Now here's what's crucial. They're telling us it's a similar. So I can assume, all right, well, if this is 9 times bigger, it must be 3 times bigger in this direction, and it must be 3 times bigger in this direction. So if I know it's similar, I can assume it, but if I don't, I can't. So this 8 times 3 is going to be 24. This 4 times 3 is going to be 12. This is going to be 15. This is going to be 30. This is going to be 39. And this is going to be 12. So I get these, if I add them up, my perimeter here is going to add up to be 44. If I add up my perimeter here is going to be 132. And I know, because the ratio, if the area is 9 times bigger, that the perimeter should be 3 times bigger. So 44 times 3 should equal 132, and it does. So feel pretty good about that. Again, I apologize. I made a little bit of a mess of this video, but I think I saved it enough to leave it up. I guess I'll watch it back and see what I think. And if you ever see this, I guess I thought it was good enough. Have a good one. Bye.